Ugh. Okay, so again, just a quick review from the last video. What we did, we were able to get data, and we were able to sort it. As a matter of fact, I'm going to do it real quick. So you guys didn't do it. If you want to, well, no, I won't do that again. But we were able to get the data from the other table. We were able to sort it from the biggest to the smallest. Okay. And then next to it, we created a row that went from 1 to the end of the data, in this case, specifically 100. And we went over here, copied it, went to Desmos. Where's my Desmos? Hold on. Again, once we had the data and we copied it, we went over to Desmos and we pasted it in, and we get this. So as a matter of fact, I'm going to do it one more time real quick. How about that? So I got a copy, and I'm going to just hit Control V to paste it in, and boom, I get a table here, and then you can see the data plot of all the different points. Okay, so now that we got that, we're ready to basically run a regression. We've done it before, but we're going to go ahead and do it again. So two things we can do. Well, I'm going to scroll down here so I can create a new field underneath the table. I'm going to click on it. That opens up another field. And then I'm going to enter in the command that's going to run a linear regression. So how do I do that? We go Y1, because remember, if you scroll up here, it tells you that this table gives you X1 and Y1. So you got to make sure when you do the regression that you're using the same number. And then you get the squiggly line, which is right to the left of your 1 on your keyboard. So squiggly, you got to do shift, and you get that squiggly line, okay? And equals A, or we'll make it M, because M is your typical slope, right? So you go M X1 plus B. That formula should look very familiar because it's the slope, it's your linear function equation. It's like Y equals MX plus B, right? It gives you the function. And if you look at what was created the moment we entered that in, it created that purple line. At least mine's purple, but it created a line that goes right through your data, right? That's modeling your data is what it's doing. So that is basically going to end up being your demand function. Because what do these numbers represent? Again, at a price of 400, it basically is saying that you're not going to have any customers. That's too much. That's kind of like the limit of what people would pay. But then as you go down it, you'll start to see different combinations. Okay, well, if you made your price, say, for example, about 300, which it looks like it'd be about right here, you click on it and you might get about 25 customers, right? Or you could look at it the other way and say, well, if I had 40 customers, if I have 40 customers, what price would I charge so I could get 40 customers? So I could charge $246, right? And I'd be able to get 40 customers. Because sometimes you have quantity. Sometimes you have, like, let's say you have 100 bicycles, and you decide, okay, I got 100 bicycles. How much should I charge for these bicycles to make the most money possible? Or 60. We'll make it on this demand function. I got 60 bicycles or whatever I'm selling. How much should I charge to get the most money possible? Well, based upon my demand curve, it says I could charge like 166 bucks for each bike, and I'd be able to get 59 customers, 60 customers, right? So again, that's what a demand curve does. It tells you combinations of quantity and price that people would pay for that quantity. All right, well that's it. So at this point we've got everything that we need to be able to take the data that we got from that form of all the prices people bid on it and start doing what we've already been doing, which is take this demand curve, turn it into a marginal revenue curve, and then, and as a matter of fact, if we want, we could actually use Desmos to do that, because what is our equation, right? Our equation is saying the slope is like 3.98. That's pretty much 4, right? I can make it my equation -4. And if that's the case, what is the slope for the marginal revenue function? Well, we take that slope, the -3.98. So I'm going to go ahead and make this y equals, I'm going to go -8 because I'm basically taking this -3.98, which for me is close enough to 4, plus, plus 404. Oh, wait a minute. I need to put an X in front of my 8, don't I? Yeah. Okay. So I need to put an X in front of the 8. Basically, why did I write this equation down? Because basically it's this equation right here, with these parameters where the slope would be -4 basically, and I'm doubling it to make it -8. And if you do it right, you'll see that this line right here that has the same y-intercept, it's just that it goes down twice as fast, or it's twice as steep. Instead of having a slope of -4, it's got a slope of -8. Why would I want to do that? Do you guys remember? Well, because if I have my marginal cost, let's say my marginal cost is, I don't know, let's say it is $200. That's how much it costs me to make this product, right? Every time I make it. So then that tells me that my marginal cost would be equal to this marginal revenue, where this red line connects to the black line there. So what it's telling me is I should charge $200, and I'll sell 25 of what I'm selling, and I'll make the most money possible. All right, I know I've talked about it a lot, but what the main thing I want to make sure you get is, once you get the data put into the graph, this is the command that tells Desmos, hey, create a line that models that data, that basically goes through the data as accurately as possible. And then I'm going to use that line to figure out what I should charge for the product. All right, so that's pretty much it for this.